Okay, question 2 talks about taxi driver, tells me the kilometres it travels per day is given by normal distribution with mean 400 and standard deviation 70, so variance 70 squared. Let's go. It talks about kilometres per week. So I need to work out the distribution for the kilometres per week. Now the weekly kilometres comes from the kilometres day 1 plus the kilometres day 2 plus so on. Now the important thing here is that this is very different to 7 lots of t. That is not correct here. What you're doing is you're adding up 7 separate observations of t. You're not taking one value of t and multiplying it by 7. So that is key to this particular question. Once you've got that, it's then relatively straightforward to work out the mean and the variance of that particular variable. So I can work those through, adding up the separate ones, and I then get the mean of 2800 and the variance of 34,300. So I know the normal distribution for the weekly kilometres. So once I've got that, I can then use my calculator. Oh, I've got the wrong variable in there. That should be a W. W bigger than 3000 is 0.140. I get that from my calculator. On to part B. I'm introduced to another taxi firm, Grub. So I've got the details there that are given in the question. The first part here, I just need to turn the question into algebra. It asks me for the probability that the taxi driver travels at least 100 more than the Grub driver. So that's the algebraic statement there. In order to answer this question, I want to rearrange that to think about that variable. So I need to find out the distribution of t minus g. So I can do that using my knowledge of expectation and variance. E of t minus g is just E of t minus E of g. So that comes out okay. The key thing in this question is to realise that if you subtract two variables, you still add the variances. So I've got to make sure that I'm adding these variances, so the variance of t minus g comes out to be 11,300. Once you've got that, you're pretty much done. You know the normal distribution, so you can go to your question, probability of t minus g bigger than 100, use your calculator, and you get the answer, 0.681. Moving on to part 2 of section B of question B. It asks me the probability the taxi driver travels at least 50% further than the Grub car. So this time I'm multiplying by a factor of an increase of 50%, so at 1.5g. Similarly, I just need to rearrange this so I know what variable I need to investigate. I'm interested in finding out the distribution of t minus 1.5g. So here I go again, similar steps. The expectation of this is E of t minus 1.5 E of g. The 1.5 comes out quite normally on the expectation, so that leads me there to 25. The key thing here is that, again, I'm subtracting variables, so I need to make sure I'm adding. Always add the variances. And if you multiply a variable, it comes out as a factor squared. So those are the key things for this question here. That leads me to a variance of 19,300, which tells me the distribution that I'm going to use. And as soon as I've got that, I can go back to answer my question. Probability of t minus 1.5g bigger than 0. I've got the distribution. I can use the normal CDF function to get the answer, 0.571.